Hi dear friends, good morning to one and all. Dear friends, in the last part of the video, we discussed about the various chemical properties of aromatic compounds with the help of example known as benzene. And there we discussed about the different types of the reactions shown by the benzene, which is the characteristic of aromatic compound. And we came to that the aromatic compounds like benzene shows a characteristic reaction known as electrophilic substitution reaction, and in that we discussed about the various examples of electrophilic substitution reactions of benzene like nitration, sulfonation, halogenation, alkylation, which is also called as the Friedel-Crafts alkylation, and Friedel-Crafts acylation. Apart from this, now dear friends, today in this part of the video we are going to discuss about the chemical properties of aromatic compound if some substituents are present on the aromatic compound like benzene. So what will be the behavior of compound if already some substituents are present on the benzene, then how it shows a behavior towards the electrophilic substitution reaction. So today we will discuss about the chemical behavior or the behavior of monosubstituted benzene or monosubstituted aromatic compounds. Dear friends, as far as concerned with the electrophilic substitution reaction, we came to that benzene or the aromatic compound, these are the nucleophilic in nature, and that's why they show the electrophilic substitution reaction in which one of the hydrogen of benzene is replaced by means of electrophile. Today in this part we will discuss about the electrophilic substitution reaction of monosubstituted benzene. Then here already we came to that the electron density on benzene ring may be is already present, but this electron density of benzene ring can be increased or decreased. It means it can be changed, and that change depends upon the nature of groups which are already present on the ring. So if some groups are present on the ring or the benzene, then it is possible to increase or decrease the electron density of the benzene with the help of group, and it will depend upon the nature of groups which is already present on the benzene ring. And definitely hence the substituted benzene ring may be activated or it may be deactivated towards the electrophilic substitution reaction compared to unsubstituted ring. Actually this is very important. Whenever we will talk about the substituted benzene ring and unsubstituted benzene ring, then the rate of reaction in case of substituted ring will be different as compared to the unsubstituted benzene ring, and it will depend upon the nature of groups in which are already present on the benzene ring. So here, dear friends, we have the two types of the groups. The first groups are called as the activated groups, or then the ring is called as the activated aromatic ring or the benzene ring. If the electron donating or releasing groups are present on the benzene ring or these are directly attached to the ring, then the electrons are shifted towards the ring due to resonance or the inductive effect, and due to this there is an increase in electron density on the ring and it becomes activated towards the electrophilic substitution reaction, and then the activated groups are saturated and they generally have one or more unshared pair of electrons. In this case the electrophilic substitution reaction will be very easy, and these are the groups actually like the groups like OH having the two lone pair of electron, OR, NH2, NHR. So these are the groups which are electron donating groups through the resonance effect on the to the benzene ring, and that's why in these groups are electron donating groups, electron activating group, and in this case the benzene ring is called as the activated benzene ring. So here if such type of the groups are present on the benzene ring, then these groups gives electron density to the benzene ring through the resonance effect that we call it as a delocalization of pi electrons. So here you can see there is a shifting of this electron density from oxygen in the form of its unshared pair of electron to the benzene ring, and that's why benzene ring becomes more electron rich as compared to the unsubstituted benzene ring. So in this case the electrophilic substitution reaction becomes very easy. So also In case instead of this the halogens are present, then the halogens shows resonance effect, electron donating resonance effect, but at the same time it also shows the electron withdrawing inductive effect. And in this case, the inductive effect is stronger than the resonance effect, and that's why if the halogens are present, then the electron density on the benzene ring gets shifted towards the halogen, and that's why in this case the overall effect is that the electron density on the benzene ring is reduced due to the inductive effect, which is stronger than the resonance effect in case of halogen, and hence the chlorobenzene is actually deactivated, and electrophilic substitution reaction in this case is very difficult. Dear friends, another types of the groups which are responsible to decrease electron density of the benzene ring, these groups are called as the deactivated groups, and in this case the aromatic rings are called as the deactivated aromatic rings. If the electron withdrawing groups like this, NO2, COOR, carbonyl, aldehydic carbonyl, then carbonyl of carboxylic acid, cyanide groups, these groups withdrawing the electron density from the benzene ring, and these electron density are taken away from the benzene ring by these groups due to resonance and inductive effect. Hence the electron density of the benzene ring get reduced and it get deactivated towards the electrophilic substitution reaction, and these groups are unsaturated groups generally, which are responsible to withdraw the electron density from the benzene. Here one example that we can see here, NO2 groups. Here you can see the electron density is shifted from benzene ring towards the nitro group. That's why the benzene ring becomes deactivated, because the electron density get reduced on the benzene ring because of the groups present on the benzene ring like NO2, C double bond O, like this carbon. So in this case we can conclude that in the above compound like nitrobenzene, benzaldehyde, benzonitrile, acetophenone, etc., the electrophilic substitution is very difficult, and due to deactivation of benzene ring, and hence more drastic conditions are required for the reaction to take place. So dear friends, one thing should be clear to you all: if the electron donating groups are present, then the benzene rings becomes activated, because the electron density get increased on the benzene ring, and it get activated towards the electrophilic substitution reaction, and hence the electrophilic substitution reaction will be very easy if the electron donating substituents are already present on the benzene ring. Instead of this, if the electron withdrawing groups are present on the benzene ring, then the electron density of benzene ring get reduced up, and it becomes deactivated towards the electrophilic substitution reaction, and the electrophilic substitution reaction will be very difficult. So this is one thing. So in short, we can say that the electron donating groups are called activating groups, while the electron withdrawing groups are called as the deactivating groups. So this is very important regarding with the monosubstituted benzene or the monosubstituted aromatic compound. So what will be the effect of substitution on their direction, influence on the rate and on the rate of reaction? It means that if the electron withdrawing and electron donating groups are present, what will be the effect on incoming electrophile as well as rate of reactions? So the one thing is already clear to us: if the electron donating groups are present, then the reaction will be very easy. It means the rate of reaction will be greater. And if the electron withdrawing groups are present, the ring becomes deactivated and reaction will be difficult. It means that the rate of reaction get reduced. But what will be the effect of position or the direction of incoming electrophile if the electron donating and withdrawing groups are present? That we will discuss in this part. Here the two types of the groups are present. One is called as the ortho and para directing group, another one is called as meta directing group. So if monosubstituted benzene undergoes further electrophilic substitution reaction, then the incoming group may enter any one of the three positions, either ortho, meta or the para, with respect to the original group. What is the nature of original group? That will decide the position of incoming electrophile. So usually we got the mixture of these three isomers obtained, but some of them are predominant depending on the nature of the groups already present, and we found the two types of the groups. If what the first type of the groups are called as ortho-para directing groups. If these groups are present on the ring, then the new incoming substituent or the electrophile will be directed to ortho and the para position, and these groups are generally having at least one electron pair on the atom which is directly attached to the ring, and these are electron donating groups like OH, NH2, NHR, or C6H5. So O minus, these all are the electron donating groups. It means that if the electron donating groups are present, then the incoming new electrophile will goes to ortho and the para position. It means that the electron donating groups are called as ortho para directing groups. So all this here we can show you. Here for example OH, which is the electron donating group, then the incoming electrophile nitro group, it will either go to the ortho position or it will go to the para position. Definitely their percentage is considerable. Instead of this, if the meta directing groups are present, then the next incoming new electrophile or the group directed to meta position, and thus meta isomer will be the main product, will be the major product of substitution reaction, and these are the groups which are meta directing NO2, CHO, CO or COH. All these are the electron withdrawing groups like nitro groups. So if the electron withdrawing groups are present, then the incoming electrophile goes to meta position. So meta product, meta dinitro product will be the major product. So one thing should be clear to you all on, or we can conclude one thing: if the electron donating groups are present, then the aromatic ring or the benzene ring get activated, and incoming electrophile will goes to either ortho or the para position, or it goes to the ortho para position. Instead of this, if the electron withdrawing groups are present, then the ring get deactivated, rate of reaction get reduced, and the new incoming electrophile will goes to meta position. It means that electron donating groups are ortho-para directing groups, while the electron withdrawing groups are meta directing groups. Again, electron donating groups are activating groups, and the electron withdrawing groups are deactivating groups. So here we can say that if the electron donating groups are present, then the ortho as well as para position becomes electron rich position. That's why incoming electrophile will goes to either ortho or the para position. Instead of this, if the electron withdrawing groups are present like nitro, then the ortho and para as well as ortho as well as para position becomes electron deficient, and that's why incoming electrophile, which is also electron deficient, will prefer the meta position instead of either ortho or the para position. So this is the reason why the electron file goes to ortho and the para position if electron donating groups are present, and why the electrophile prefer to go to the meta position if electron withdrawing groups are present. So this is all about the directive effect of substituent present on the benzene ring as well as rate of reaction of the benzene ring if already some substituents are present on the benzene ring. So dear friends, here in this way we try to complete this discussion of aromatic hydrocarbons with the study of its classification, nomenclature, classification, chemical reactivity, as well as directive effect of monosubstituted benzene and the rate of reactions of different monosubstituted benzene. Here this is all about the aromatic hydrocarbons. So we have already completed all the content of this aromatic hydrocarbons. So we have completed this topic, and in the next part of the video we will look to complete the remaining part of the syllabus, and that is the discussion regarding with the solid state chemistry. So here in the next part of the video we will start the new topic based upon the same unit, physical chemistry, and that is entitled as the solid state chemistry. Thank you very much.